This is Sohan Nivale, and in the video, I'll be explaining about one of my projects made in Unity game engine called as MOS, an operating system simulator. MOS is nothing but multi-programming operating system simulator. So this was written in C# language, that is uh, the main language for Unity, and it was uploaded recently on Play Store. Currently, I believe it is in review, but it would be soon available to public. And before putting it in an app bundle, I have converted it from C# to C++ using the Unity's default build system to make it faster and better for publishing. So a brief description about this system. It was done in Unity version 2021.3.19 F1. This is a main version of Unity that I like to use. The platform is Android, so the application is nothing but an Android application, just that it has been developed in Unity. Then it is released under the name Sleepwalker Games, which is my username on Google Play Store. The privacy policy is also present here if anyone wants to check it out. So this is it about the overall description. Uh, then this is a public repo. I have not explained the code in the video. I have only explained the basic working and the purpose of various things included in the project. So if anyone wants to check out the code, they can use this repo. I'll be providing a link wherever I feel it is appropriate. And this is a third patch on the GitHub. I have first made two patches before it. The first patch was when I completed the menu scene that you'll see soon in the Unity editor. Then in the second patch, I have completed the basic logic of phase 1 and phase 2 and addition of a little bit of UI. In the phase 3, this was a major upgrade. I fixed as many bugs as possible from both the phases and even added a few additional UI to the same. And currently there are no issues, but the remaining task for the patch 4 is the implementation of phase 3. So if anyone is interested in collaborating, it would be great if they could help me build the phase 3 since it is a lengthy project. Now moving on to the Unity editor to explain the application. In this major project, my main focus was to learn about UI, how to manage UI, how to be concise with UI, how to have relative UI instead of static UI, so that if the screen resolution changes, the UI should not be, it shouldn't be like static. It should change according to the size of the screen. So that is something that I learned from it. So I will give an example of using, say, layout groups in this project. Like in UI, in Cover Dash, I did not use any layout groups. I manually put the buttons. But I later realized and learned about layout groups where I can group various buttons together. Let us I'll enable the main menu. You can see these three buttons, the start button, the settings button, and the quit button. They are a part of the same vertical layout group. So it looks better this way, right? So that's something I learned while doing this project. And there are many other things like I learned some in-depth insights of using Text Mesh Pro. Text Mesh Pro is very, very useful, and with it I was able to get input from user on phone keyboard. Like this is a input create file menu. So a user can easily tap this text window and they can enter an input field. And yes, it is very important to be careful. Like the text mesh pros last character of an input string is a garbage value like /r or something garbage, basically not r, something that is not r used. So if I enter, say, a string SOHAM, SOHAM, then the input from text mesh pro's input field will not be equal to the string SOHAM. The reason why is because the text field input is not only SOHAM but another final character, that is a sixth character, that is a garbage value, say /r, that is a return character. So this was a major bug in this project, and it took me very like long time to realize it. So I would like to highlight that that is something that I found out, and uh, it was pretty helpful. And I don't think I will forget it after this. So yeah, it would help even save others time if they are facing the same issue. So coming back to the main project, I'll briefly explain it in about the next 2-3 minutes, and then I will give a basic demo of it. So yeah, from coding point of view, I will first show the scripts. Just a second. Yeah. So these are the UI scripts. The first scene of this project consists of various UI like create input file, delete input or output file, create output file, edit input or output file, the main menu, the settings, the setup, the start menu. Basically, all those UIs are put into these UI objects, and there is no game mechanism involved in this. It is complete play of UI. The second part is machine part. The second scene is a machine scene where we have phase one, phase two, and phase three. Phase three I have not completed yet because it is a very lengthy task. So these are the phases. Each phase is given to a particular machine in the second scene. You can see here there is a phase 1 object, phase 2 object, and phase 3 object. Along with it, we also have separate canvas for UI, for phase 1 UI, phase 2 UI, and phase 3 UI. I have separated the UI from the main logic, and it is also good practice to do this in Unity. Even here, the scripts are separate for visuals for both phases and for the actual implementation of the game mechanism. Uh, Now I would skip the code part because the video would be a bit too lengthy. The code part is very similar to the algorithm, the standard algorithm of a MOS, that is a multi-programming operating system. There is also a good practice that I implemented. That is, I created a game handler for the machine scene. So it will handle all three phases as a like a wrapper around all the three phases to control them, each of them. And in order to handle files, that is in IO in an Android device, it was a very difficult task at the start. But later I uh, learned a lot about Android game applications and what is Gradle and what is Android manifest file and so on. And it was easy to build a basic IO system for an Android device in the internal storage. And this file handler is again separated because it is independent of any machine, phase 1, phase 2, or phase 3, and even the UI. So I kept a separate folder for it. The file handler has various abilities, like it can do read task, write task, append task, it can create file, it can delete a file, and yeah, many other tasks. In this part of the video, I'll be presenting a demo for the application. So first of all, this is all a relative UI as explained in the main explanation part of the video. So even if the screen resolution changes, the application will be like updated to be as presentable as possible. Then we have the settings menu. It is a draggable uh, menu, and currently I only have one settings, that is operating speed. This is a value in seconds, and the maximum operating speed per operation is 5 seconds, after which it will reset. Let us set it to 0.5. so there is not much delay in instruction execution. Then we have the start menu. In the start menu, we have multiple options. First, we have the create input option, input file. Let us create an input file P1 and paste an program that has been written in advance. So yeah, we will save it. Once it is saved, we'll go to start menu. We'll create an output file. So P1 out. We'll save the file as well. The output file will be empty by default. If we want to write something uh, before the like the empty file, so that let us say author's name as Soham Nimale. So yeah, we can edit the file, but let us skip this part for now. Then we also have a delete file option. We can choose whether it is an input file or output file, and you can type the file name and delete it. And let us skip again this step for now. When you have run machine, which is the main where we will be redirected to the setup UI. This is the last step before we actually run the machine, where we select the input file as P1, the output file as P1 out, sorry. Then we will start the machine. Now, as you can see, after every 0.5 seconds interval, our machine is running one instruction at a time. Let us take a look at the full memory block. This is a second phase, so the instruction will not start from 00. It will start from 00 in the virtual memory, whereas because of paging in the physical memory, it will appear at any random page that is assigned by the page table. So here it is 6th page, that is 60th instruction location. This is also not the complete instruction. I believe it would be present somewhere else. This is a data card or the data block. Then this is a page table, and it is noticeable that uh, the page table consists of dollar signs and as the default character, so it is easily understandable that which page has been used. Then we have this data example that is not palindrome, and this is the instruction that I talked about before, that the first one was incomplete. This is the other part of the same. Let us take a look at the block memory. The block view is a bit interesting. I have written all the physical memory blocks over here. The yellow ones represent the data, that is the say A or not palindrome that we just saw. The instruction, there are two blocks, again as we saw in the whole memory. These represents the instruction pages. Then we have unused pages that can still be appointed to any virtual memory, uh, anything present in the virtual memory. Then you have the page table, that is 16th. Page table is highlighted as a different entity. And finally, we have a CPU and a kernel UI. In the kernel, we have SI, TI, PI for the various interrupts. And in the CPU, we have register, general purpose register. IR is instruction register. IC is instruction counter. C is the toggle, say true or false, that can be used for Boolean operations and branch transfer. PTR is the page table register pointing towards a 160 instruction, 160th address, that is 16 into 10. At the 160th address of the physical memory, there is a page table. We can confirm it from here. At the 16th block, that is 160th position, there is a page table. So this is the basic working of the this project. We can pause the machine at any time using this button. Currently, all the instructions have been executed, so I can't really show this functionality. But yeah, yes, it can be used to pause the machine. We can resume it back. Then, using the back button, we can navigate back to the original main menu.